Welcome to Vector's Patreon tutorial. In this section, I will create a cylindrical notched ornament. You can learn how to implement a reliable mesh Boolean in Sverchok. First, we need to create two base geometries. Set the cylinder as a long cylinder with hollowed ends. Use solidification to add a little thickness to it. Next, we need to create some spheres. The spheres need to be distributed around the cylinder. In order to keep the instantiated spheres always in the same grid, I use the matrix apply to mesh node. It is possible to instantiate a sphere with multiple matrices. Here I use the vertex coordinates of the line to define the position of the sphere. The number of vertices will define the number of instantiations. At this point, we get 5 spheres inside the cylinder. Next, move them to the surface of the cylinder. And let them rotate randomly around the center. Rotate the random values generated by the random number node. Note that the number should be the same as the number of vertices. Now we are ready for the base geometry. By far the best way to implement the Sverchok Boolean function is with the help of the Blender Boolean modifier. So, we need to export these two geometries as Blender objects. A Blender object can be seen as a geometry type in the Sverchok process. You can add Boolean modifiers to it manually. But I've wrapped it here as a script node. You can use this script node to quickly execute the grid Boolean. Then, the results can be imported into Sverchok again. Note that the application modifier needs to be switched on here. In this way, we have implemented a fast and reliable grid Boolean in Sverchok. And this is all procedural. We can continue with the post-Boolean result. I will distribute it into the square matrix. The position data of the square matrix is provided by a subdivision plane. Again, the matrix applied to mesh nodes is used here. Input the vertex data of the subdivision plane into the matrix. This instantiates the geometry to the vertices. Next, I will perform some randomization effects on the position and rotation. First, move them up a distance overall. Use some random numbers to control the strength of the upshift. The number of random numbers should be the same as the number of vertices. In this way, we achieve a random offset of the z-axis. The geometry is a bit loose, so I've adjusted the distance between the vertices. Next, some randomization is performed on the rotation of the matrix. Finally, we get a randomized cylindrical ornament like this. The object Boolean script is stored in my video attachment. You can download them in my Patreon.